right, let's see if the audio is up here. I don't know. Yeah, the audio seems to be going through. So good morning to you all. I hope you guys are doing well. Okay, so let's see where are we at here. We're gonna talk today. I'm gonna give you guys a little bit of S this morning. S, you go, what is S? Well, let's give you guys some ideas about functions and inverse functions. So a little bit of supplementary material. Now remember, to do some of that supplementary, I'm going to use purple here. So in purple, let's ask you guys to recall, well, do you guys remember what a function is by any chance, right? We've been really working with functions. So what's a function, if you guys ask you guys here? You guys remember? Because we're going to have to talk about a function to talk about an inverse function, so... All right, what do you guys think? What's a function? Do you guys know? You can think of as a function as a machine, okay, that assigns an input, it assigns an output to an input. I'm going to move all this stuff out of the way. Okay, so, you know, this is some S for you guys, some supplementary material. We'll call that S. Because we're going to work with inverse functions. All right, so we're going to have to know a little bit about some of these things. So you might say, okay, a machine that assigns, you know, an output to every input. So my favorite example of a function, to very simply express this to people, and we use that scripted F, if you guys remember. You know, my favorite example is, think of a juicer. Okay, so if you had a juicer by any chance, you might say, what kind of things can you put inside a juicer? Here's going to be my letter X. Right? So we have a juicer now. Okay. I'm sorry, Isabella. There you go. There it is. There you go. So here's the deal. Here's a definition of a function. It's a machine. You can think of it, it's really not a machine, but I want you guys to think of it that way. It's really a rule, but okay, that assigns an output to an input. So you have some things you can put. You have some inputs, and I'll color that, for example, orange. Okay. So what kind of things can you guys put inside a juicer? What do you guys think? What goes inside the juicer? You guys know? What could you put in a juicer? Maybe you can put a what? An apple, right? You could drop an apple in a juicer. What else could you drop in there? Maybe a pear. Maybe a beet. All right, you guys know what I'm saying? What else can you put? Maybe you can put, I don't know, what else can you put in a juicer? Carrots. And if you do that, what do you guys get as outputs now, right? So here's kind of the idea. You're going to get a particular output for all of these inputs. So if you drop an apple in your machine, what should you expect? Maybe apple juice, right? If you drop a pear in, what should you get? Pear juice, okay? If you drop a beet, what should you get? Beet juice, okay? You guys see what I'm saying? And then if you drop a carrot, you get carrot juice. So what I like to express to you guys here is this. You're looking at, ladies and gentlemen, the real idea behind a function. Okay, and in terms of notation, you have this f of x notation. So the input, if you guys remember, is x. The output is really f of x. All right, so here we go. And very often we let y be f of x. So just to kind of remind you guys a little bit of this stuff here, if you're taking Math 260 or even an intermediate algebra, this is what they work with. Okay, so they work with functions. In other words, you say, how does this fit together? Here's kind of how it fits together, right? You can say f of apple. If I drop an apple as an input, that's my input. I should get as an output apple what? Juice. Output, right? I'm sorry, I think I got the colors wrong. Yep, got the colors wrong. Okay, so if my input is an apple, the output is what? Apple juice. Okay, that's function notation. This is the notation that we use here to describe everything we just did. And another example is if you said, okay, what if we put the pear? Well, if we drop the pear in, we'll get pear juice. So if my input is a pear, the output is pear juice. All right, all those kind of things. And if I said to you guys, hey, drop in a beet as an input, you should get what? Beet juice as an output. So I have my input, have my outputs. And you say, okay, what if we put the carrot in? All right. Then we should get carrot juice. Oops. Let's double check that we spell carrot okay. All right. So what I want you guys to understand here, going over some S, drop a pear, drop a beet as an input, carrot as an input, we're going to get these output values. Okay? So here's the general feeling behind a function here. All these outputs. All right. Okay, so does this kind of ring a bell for people? Right? You guys remember that kind of stuff? Because, you know, what we're going to talk about today, which is kind of amazing, just to go over this idea, is, all right, what are we going to say today with this? All right. What about working in reverse? All right, let me give you a definition first. So if I said, I'm going to give you guys this definition here. Definition of the domain of the function. Do you guys remember, what's the definition of the domain of a function? We have a definition of a domain. And the domain, ladies and gentlemen, is defined to be the set of all input values. Okay, that's the domain of a function. So if your inputs in this example here is, what should we say? What kind of things can I put inside a juicer? What do you guys think? What things do you put in a juicer? You might say, oh, in this example, my domain, and I'll use set notation, is a set of all x such that x is a what? A fruit or a what? Vegetable. Okay? So this is how we define the domain of a function. Now, what's the definition of the range? So this is important here, ladies and gentlemen. The range of a function, another important idea, well, that's the set of all output values. Okay, so you have what we call the domain, and we have the range here. So in this example here, we can say, and we let y be the value, because y is f of x. What do you guys think we get? We're going to say y is going to be a what? A fruit juice or a vegetable juice. Okay, so just to kind of express to you guys how that works. Okay, you got your x values. And you got your y values. So kind of just talking about a little bit of supplementary material here about what a function is. And this is the very famous f of x notation. Okay, so you got f of x. Okay, that's not multiplication, that's input output. And we like to say y equals f of x. Okay, does that look familiar for you guys, remember? Going over a little bit of some supplementary material. Let me get something here. All right, you guys look at that there. All right, now you say, but what do we mean about inverse functions? Do you guys know what we mean about that? What's an inverse function? Right, an inverse function now is going to be when everything works in what? You want things to work in what we call reverse. So you should really think of this as not just a what? What do we say? You should think of that as a reverse function. They should have called that a reverse function, right? Not an inverse function, but a reverse function. So essentially, this is what we're going to do. You switch the x and what? Y values. That's what this is. You get to switch the x and y values. So you might say, what are you talking about? Yeah, let's think about it this way. This is how we work now. This is a function. We're going to look at what's called an inverse function. The notation they use is this. This is going to be that -1 power. This is not a reciprocal. Okay? This is not a reciprocal, ladies and gentlemen. That's an important thing to know. Okay? And I'm going to do something here really quick for you guys. I'm going to say, take a look here. I'm going to restart my my iPad. It seems to be a little slow for some reason. I'm not quite sure why. So I'm thinking I'm going to restart it, just so you guys know. So just give me a few seconds here. And what I'll do here then is, how about this? Let's focus on the browser. All right, folks, we're back. And you know something? I think it worked. So, you know, we're not going to be slowed down by this. Okay. There you guys go. But I think we need to put our audio. Yeah, our audio's on. All right, folks. How does this thing work in reverse, right? So here's kind of the picture I want to draw you guys. okay, we're going to use this inverse function notation. This means inverse function. It's not reciprocal. So how you would do that, it's like you say, oh, do I drop a y into this machine and then I get f inverse of y, and that's your x value? And the answer is yes. I'm going to share with you guys that idea here. So you might say, what does that mean now? Right? So what that means is if you drop in apple juice, if you want this machine to work in reverse, what do you think you get? If it's going in reverse, what would you get? You get an apple. Does that make some sense? Did you guys see what I'm saying? And then if you said, what if I want to put in this pear juice? Well, what would you get? If it works in reverse, this thing will be what? You'll get a pear. You guys okay with that? So we're working in reverse. What if you have, for example, what was the other one we did? Pear, apple, beet juice. So if we put in some beet juice, we're going to get now a what? A beet. And then, what's the other one? What's the last one we did? Carrot. So if you put some carrot juice in here, you should get a what? Carrot. If this thing works in reverse, in other words, you are switching the domain and range. Okay, so that's kind of the idea here. You switched the what? Domain and the range value. So this is kind of the discussion I give the 125 students, okay, intermediate algebra students, on a function and what its reverse, or really we call it a what? An inverse. So ladies and gentlemen, I don't know if does this clear out any cobwebs from you guys in your lives, you think? Maybe, you know, because you might say, Mr. Judge, what does this have to do with anything? Well, we are now, remember this here. Let's ask you guys another question from that, since we're doing some S, supplementary material. Let's ask you guys another question now. See if you guys remember. What functions have inverses? Because not every function has an inverse. See if you guys remember. Anybody remember this stuff from past math courses? Right? What kind of functions have inverses? Not every function has an inverse. You can't do this for this idea here for just any machine, right? If you guys remember, what kind of functions have inverses? What's that? Well, before all that, like if I said to you guys, I'm going to go out to Desmos here. Okay, you guys can get to see my good old Desmos, since this is a discussion. Oh, since I rebooted it, everything was gone. All right. And you guys know I don't like using red for my machines. So you see this picture? Maybe give you a different picture. Okay. Does that function have an inverse? You guys know what I'm saying? So here's what I'm saying. Does that function have an inverse? The answer is no. And you go, what do you mean it doesn't have an inverse? You guys remember what kind of functions have inverses? Especially if you're taking those other like classes. Like, don't tell me you're in a pre-calculus class and you're earning an A, but yet what's going on? You don't know about any algebra or any functions or graphs. Then something's wrong with that picture. I'm going to say, who's that instructor? How much did you pay them? How do I get in on that deal? You guys know what I mean? It's funny, but it's not that funny. So do you guys remember not every function has an inverse. You say, well, what kind of functions have inverses? The only kind of functions that have inverses are those that are what? 1 to what? 1. All right, one-to-one functions. You guys happen to know what that means, by the way? One-to-one. Just kind of, since I'll give you guys some S on this, right? So, give you guys the kind of intermediate algebra kind of lecture on all this that I've done in my life. What kind of functions are what does one-to-one mean? Give you guys a definition, although you're not going to use that here. And it's going to be for completeness. I'll give you a definition. We say a function f is one-to-one, okay? If what? If different outputs or the same outputs imply same inputs. This is really the formal definition of being one-to-one, okay? Well, I want to give you guys a note. Other books might give it to you this way. They might say if you have different inputs, then you must have different outputs. This is the equivalent version of the criteria. You need to satisfy this criteria. And that means really different inputs, because A and B are inputs, guarantee different outputs. So different inputs guarantee different outputs. Okay, this is what it means to be one-to-one, by the way. Now, the function I just shared with you guys, by the way, is this. And again, this is just the S portion. So you go, Mr. Judge, what is the supplement portion? This is kind of all the ideas that, they talk about for S. This is kind of like a review of things you know. Different inputs guarantee different outputs. So if this is my function, right? Here's the problem with that function, x squared. If I said to you, do you guys know what is f of -1? That's -1 squared. In other words, if I plug in the input of -1, what's the output? +1. So here's an input. Here's an output. You guys okay with that? If I plug in +1 and I square that, you say, what do I get? Well, here's an input. Here's the output. So the very reason, right? Because remember, this is an input. Input. Output. Output. Sometimes it helps people to see the colors. Input. What's this? Output. See how fast that is now? You see how fast the iPad is? Oh my God, it was just driving me nuts. So here's the problem, ladies and gentlemen. What I just shared with you guys is this. That -1 is not the same as +1. Those are the two inputs. Oops. I'm doing that badly. These are the inputs. Okay? So I plug them in there. Those inputs are different. I just did this portion now. And then what did you guys notice about my outputs? Right? 1 is the same as 1 because this is now what we're saying is f of -1 is the same as f of 1. Now, this is the real formal definition of it. Okay? So what I'm doing here is that if you do not guarantee that these are different, we can't say it's one-to-one. This is the criteria for being a one-to-one, that different inputs guarantee different outputs. And that is not the case for the x squared function. And so what that means, ladies and gentlemen, is that this function, x squared, is not what? 1 to 1. Okay, do you guys remember this from the S portion? Or, I'm sorry, from past experience? This is not 1 to 1. All right. So, okay. I'm going to look at a different function. X cubed. Okay. So you might say, is this function 1 to 1? Well, I'm going to look at the graph again because I'm showing you guys some of this S portion today. Y equals x raised to the third power. And let's change that color. I'll change it to green. Okay, and I'm not going to look at this one. Okay, you're done. Okay. This is the function we're looking at now. Is that function 1 to 1? Some of you guys know where I'm going with this. This function is 1 to 1. Now, I can prove it to you guys. This is the proof. Okay. The proof is done this way. You see, I'm going to use for the proof the equivalent version here. Right? This is an if-then statement. So I get to assume f of a is equal to f of b. I have to show that a must be b. I have to show this. So if I assume f of a equals f of b, what that means is that a cubed equals b cubed. Remember, I have to guarantee a is b. Okay? Just to let you guys know, this is where I'm going with this. Okay, because this is the classic proof behind x cubed being 1 to 1. So if I do a little bit of algebra, I'm going to subtract b cubed from both sides, and I'll get what? A cubed minus b cubed is 0. Just using a little bit of algebra. Now, also here I get a minus b. I have to solve this equation. This is a difference of perfect cubes. A squared plus ab plus b squared, that portion equals 0. Now, if you guys remember from algebra, the zero product rule means a minus b is 0. It means a squared plus ab plus b squared equals 0 here. Now, this means a is b. This here, this other equation, since this is the zero product rule, if you guys remember, this gives you here, if I recall, this gives you a complex number. Well, we're only dealing with real numbers. So this portion really gets thrown out. And so what you end up with is you guaranteed that that's the only real solution here, that a is b. And that's what we have to show. And if you can show that, this function f is 1, 2, 1. Now, I'm just giving you a lot of the background behind this because I think it's important. And then this is the S portion. You don't get homework on S. Here's the deal. You guys see what this is? Okay. Here's the deal, ladies and gentlemen. There's an easier way, does anybody know, to determine which functions have inverses. We don't have to go through the proof with every function. There's an easy way. Let me give you guys a hint. There's a graphical way. What's the graphical tool that you guys use to determine whether a function's 1 to 1? You guys remember? Back from algebra, intermediate algebra, and even pre-calculus. What's the famous graphical tool to determine which functions are 1 to 1? Do you guys know? You can use what? The horizontal line test. The horizontal what? Line test. You guys know what a horizontal line is? It's like the horizon. It's a horizontal line. So if you, do you guys know what the horizontal line test to see if a function is one-to-one? You have to, your horizontal line has to intersect the curve. You have to intersect the curve in exactly one location, everywhere on the curve. Everywhere on the curve. Okay, everywhere on the curve here. So if I go back to Desmos now, oops. Here's going to be my horizontal curve. If I say y equals 2. And I'm going to use a different color. I'm going to use red. So ladies and gentlemen, here's the idea. You see that cubic function I just showed you guys? Do you intersect this curve everywhere exactly at one location? Yes, that's a horizontal line test. This is why they teach you how to graph x cubed in some of those courses, right? This is why they teach the sketching the curve, because then you hit this curve exactly one spot. You go, it's one-to-one. If it's one-to-one, it has an inverse. So if I go to the other curve, what's the problem here? I hit, remember, you say, but at the origin, at the vertex, I hit it at 1. But no, it has to be everywhere on the curve. So everywhere else, you're hitting it at two spots, right? So this fails a horizontal line test. So this is why in those classes, they say, okay, graph these curves and tell me which functions are one-to-one. If you hit it at 2 locations, it's not one-to-one. Now you say, where are you going with this? Well, this is a trig course. Is the sine curve one-to-one, ladies and gentlemen? By the horizontal line test? What do we know? You guys tell me. Sine is not one-to-one, is it? Okay, sine's not one-to-one. You guys know what else is not one-to-one? Cosine's not one-to-one. Cosine's not one-to-one, ladies and gentlemen. You don't only hit this curve in exactly one spot. So cosine's not one-to-one. What else do you guys know is not one-to-one? I'll give you tangent now. And change that color. Come on. Tangent's not one-to-one either. So all these functions here, our trig functions, are not one-to-one. So we go, okay, well, they're not one-to-one, but all right. Why do we care about one-to-one functions? Do you guys remember? Why do we care about those one-to-one functions? There's a reason why we care. Do you guys know the reason? Because the only functions that have inverses are one-to-one functions. This is why you care. Okay, so the only functions that have inverses are one-to-one functions. Okay? So if you ever run across a function that's not one-to-one, guess what? It does not have an inverse. It's weird. What's going on here? Okay, so I'm going to let that seep in for you guys. I'm looking up something here. All right, now, remember this original function here that was not one-to-one, the x squared term? Remember this one? We know this is not one-to-one. I'll bring it down over here. But you want to know something? You guys know what I can do? I can make this function one-to-one. Does anybody remember how I can make a function one-to-one? So how can I turn this function into a one-to-one function? Right, here's the question. How can we make this function one-to-one and then therefore have an inverse? Right, how do we do that? Anybody know? Okay, there's a way to do it. Let's see if you guys remember. How can you guys do it? All right, there's a way. What do you guys think? This is what you got to do. You're going to have to do something called you restrict the domain. So you may say, what do you mean restrict the domain? Right? So if your function, like the x squared function, right, we know it's not one-to-one, but if I say let x be greater than or equal to 0, this is now my domain. Okay, I restricted the domain to just be positive numbers with 0. Okay, you guys with me on that? Now you might say, well, what does that look like? Well, go back over here. There's a way to do this here in Desmos, if I remember. You have x greater than or equal to 0. There we go. Okay? So I threw out the negative input values. I'm only including the positives and 0. They call that non-negative. So ladies and gentlemen, do I hit this curve now since I threw some values out? You guys see this here? Notice what I just did to this function x squared by restricting the domain. This is now 1-to-1. All right. Do I hit the curve in exactly one spot by the horizontal line test? The answer is what? Yes. Okay. So you might say, well, what's the story with this restricted domain? Well, now, for example, this is now 1-to-1. And if it's 1-to-1, it has a what? Inverse. All right. You guys remember the story here about this stuff? This is all S today. So we restrict the domain, and now it's 1-to-1. So now it has an inverse. So now I'm going to ask you guys this question. See if you guys remember from the past, right? What is the inverse function? You guys know what the inverse function is? Well, then you have to follow a procedure. Do you guys remember the procedure? There's a 4-step procedure. This is back in the day. You said let y be the inverse function. Okay, so I'm doing some intermediate algebra, if you guys want to know what I'm saying. So that's y equals x squared. That's my step 1. Step 2, you switch your x and y values. So now that means x equals y squared. That's step 2. Step 3, you solve for y. Okay, so you say, well, how do I do this? Well, use the square root formula. Y is plus or minus square root of x, which means there's 2 answers. Y is positive and y is negative. And then now you say, okay, what's step 4? Well, step 4 is you let the inverse function. Let y be the inverse function. So this is that 4-step procedure back in intermediate algebra. Now, be careful here. Remember we said x is positive? Because you have 2 solutions here. Okay? Which one is it? We're almost there. Which one is it? Well, if you said x is positive because you actually restricted the domain, and then you switched x and y, that now means y is positive. Or 0. So that means I have to throw this out because this is negative. It has the negative sign. So ladies and gentlemen, this is the procedure for finding the inverse function. Historically in intermediate algebra and in pre-calculus. Okay, so these are kind of the things you should be studying there in pre-calculus. But this is a very kind of simple intermediate algebra version. Because you might say, Mr. Judge, why are you bringing up all this S stuff? Because we're talking about, now we're going to talk about what? Inverse trig functions. Okay, do you guys remember this stuff? You say, well, what about trig functions? We know they're not one-to-one. So if I said to you guys, what about the sine curve, right? We know it's not one-to-one, right? What about this one? What do we do here? Well, we restrict the domain. If we restrict the domain, ladies and gentlemen, you know what we do? We can make it one-to-one. And if it's one-to-one, it has an inverse. That's the whole idea. What do you guys think? Right? You guys with me on that? We got to restrict the domain for sine, and that's what we're here to talk about. All right, ladies and gentlemen. So here's the deal now. So we're going to focus on the sine curve now. And let me actually give you, the definition in your book here. Okay? You already know. Well, let's do this here. This is what your book's going to say. Okay? They'll say let f be, well, here's what we're going to do. Y is sine x. Okay? We're going to restrict our domain to be between negative pi over 2 and positive pi over 2. Okay, now the y values are still going to be what? Between negative 1 and positive 1. You guys with me on that? So here's our sine curve. Do you guys believe that this is, let's go back to sine now. We're going to restrict the domain for sine. We're going to see that it's 1-to-1 now. So I'm going to have to put negative pi divided by 2 less than or equal to x less than or equal to positive pi divided by 2. Okay? Let's change that to blue maybe. All right, you guys okay with that? So, do you guys think, is that a 1-to-1 curve? Is that 1-to-1? You see how this is 1-to-1? So by restricting the domain between negative pi over 2 and positive pi over 2, I now have a nice 1-to-1 function. So what I'm going to do now here is this. This is what I do in some of the other classes when I use Desmos. If I do in a calculus class, I'm going to kind of input that picture. I'm going to save that in our notes here. Okay, so I want you guys to really take a look at some of these details because it's important. This is the restricted domain for sine. Notice the y values are between -1 and 1, and x is between negative pi over 2 and positive pi over 2, okay? Now, let's talk about some inverse information, right? So remember way up here when I said to you let y be f inverse, and we got the inverse function in this algebraic approach to finding inverses. We're not going to do that. But you now have y being a function of x here, an inverse function, right? That's equivalent to the statement x is f of y. And you go, what do you mean x is f of y? That goes back all the way to our picture here. Okay, remember this idea here? Right in here. So if x is, all they're saying is x equals f inverse of y, that statement is equivalent to what you see here. Okay, so now we're going to get to talk about this. So let me go back and really, let me do this for you guys to kind of really share with you guys just some details, because I think these details are important, right? So remember, if you had y is the sine function, or really originally we had this. This is what we're going to say, okay? And yes, we restrict the domain. So it's nice and one-to-one. Remember that algebra procedure? Step 1, you let y be sine, okay? Let y be the function. Step 2, you switch x and y, so you guys know what I'm saying. I want to go through that detail. So x is sine of what? Y, so you guys know that here. And then step 3, they'll say solve for y. However, here's the problem. You can't really solve for y algebraically. There's no way you can really algebraically solve for y. So that's when they say, okay, we pretend to solve for y. And this is a solving for y thing. We just now name this function the way we did. So this is a switch step. And then this step now, I'm going to try to change the color. I don't know what color, maybe blue, I don't know. They pretended to solve for y. They called that the inverse sine function. So this is the name here. Inverse what? Sine function. So that's all they did. Pretended to solve for it, and they named it inverse sine. And then they say step 4 here, okay, let that inverse function be what you just found. So this is going through the intermediate algebra pre-calculus criteria or procedure for finding this, right? And so when they define now the inverse function in your book, they go, oh, here's our inverse function. That is equivalent to x equals sine of y. Now you might say, what do you mean? They say this statement is the same as this statement. And it is. They're equivalent. So this double arrow is a biconditional. It means the same as. So all they're doing is going back to that algebra procedure, ladies and gentlemen, and they're just writing it down that way. They're saying, hey, guess what? When you have this, remember where it came from. It came from the switch step when you switch the domain and range. That's all they're saying. So in the definition here, yes, we switch the domain and range. Now, if you switch the domain and range now, what does that mean? Your inputs are no longer your inputs, they're outputs. Those are switched. So what you'll see now when I go back to sine here, right? X and Y now are going to be switched. I'm going to switch my X and Y values. So that means -1 is less than or equal to 1 for the inputs, and then the outputs are switched as well. So this is the switch. And this is all for the inverse sine function. Okay, I'm going to just kind of share that with you guys. This is where that inverse sine function comes from. Because you switch domain and range. So I'll put that in the notes. You switch the X and Y values. And that's really the key. And so now you might say, well, does that have a graph? Yeah, when you switch the X and Y values, I'm going to go back to Desmos, and I'm going to share with you guys this so you guys can see now. Y equals, there we go, there's an inverse function there. Okay, you guys see that there? I'm going to import that picture too. This is the inverse sine function. All right, so let's bring that in our inverse curve, our inverses here. Add to the existing. And maybe I just have to bring it all down. What do you guys think? I'm going to bring it all down. Okay. All right, so here's the deal. Come on, picture, you can move. There we go. So here is your inverse sine function, ladies and gentlemen, where the x values are between -1 and +1, and the outputs are between -π/2 and π/2. So that's why you see this up here. The y values are between, pi is about 3, so π/2 is 1.5, -π/2 is -1.5, and x is between -1 and 1. This is the inverse sine curve now. Okay, so this is kind of what we're here to talk about. If you guys recall, properties of functions and their inverses. If anybody remembers some of those composition of functions, right? Remember this fog back in the day, composition of functions? That was defined to be f of g of x, or I should say, let me write it this way. It was fog, but we have f inverse of x. If any of you guys remember those nice properties, right? Okay, that equals x. We also can switch the order of this fog and goth. If anybody recalls from that, that's also x. Now, this is in general about functions and their inverses. So you might say, well, what about sine and the inverse sine? Well, it holds true. Sine of inverse sine of x is x, and inverse sine of x is also x. Okay, but it depends on what the input is. Remember this, for the inverse sine curve, your inputs are -1 to +1. Okay, so I just want to let you guys know you have that criteria from the general relationship between functions and their inverses. And then this bottom one, because it's just sine, well, the input for sine, remember, is -π/2 to +π/2. And we're going to use these ideas in our future. So I want you guys to kind of see where this comes from. Okay, so we have all of these facts now. This is just for sine, by the way. Okay? So what we spent the day doing is talking about inverse functions, where they came from, what they mean, what kind of functions have inverses, and really taking the sine curve, and we're going to restrict the domain so that that sine curve has what? An inverse function. Okay, you guys with me on that? Now, just to kind of give you guys a tip for where we're headed with some of this, right? Just so you say, okay, Mr. Judge, fine, you gave us a nice long lecture. What does this mean? How do we use this? Well, they're going to ask you now to determine the exact values. And this is all without a calculator. Okay, determine the exact values, they may say, of the inverse sine of √3/2. So just to share with you guys where this comes from, or what this means. And so here's what I want you guys to do now. You're going to follow a procedure on this, okay? Here's a procedure. This is an inverse sine. It's not a reciprocal. Inverse sine of this value. This is actually an output value, okay? So how I say is let theta, this is how I kind of start to look at this. Let theta be the inverse sine here of that output value, really. It's an input for inverse sine, but it's an output for sine. Is that right? So that's an input for inverse sine, but it becomes an output for sine. Now, what does this mean here, right? You say, well, what do I do with this? We'll go back up here. Right? This is kind of like saying this is that theta. That'll be the theta. So you're going to use the definition of inverse sine, which essentially means the following. This means, ladies and gentlemen, that sine of theta is the √3/2. So whenever you see theta is inverse sine of anything, this is what that now means. This is why I'm saying that's green and this is orange, because it's an input for sine, but it's not for inverse sine. They switched. So now you essentially ask people this question. What is theta? How do you think you guys can find theta? By now, I'm going to say you guys should be an expert. What's the definition of sine? Do you recognize this? What do I want to say? Special triangle. You guys know what I mean? Isn't that a special triangle? This is opposite over what? You only have to know 2 triangles in this class. 30, 60, 90, 45, 45, 90. They're going to be specially chosen questions. So that means this is 1. Is that true? So what's that going to be? What do you guys think? What's that? 1, 2. What's the special triangle? What does theta have to be? Theta 60 degrees. Is that right? And how do we represent theta in terms of radians? Is that pi over 3? So, ladies and gentlemen, guess what you just did? You evaluated this without a calculator. This is what they're looking for. That's all. Theta is what? Pi over 3. Just to let you guys know, I'll put pi over 3 wherever there's a theta. All you need to know is really 2 special triangles. Easy peasy lemon squeezy. 2 special triangles, that's it. So, but I want to kind of leave you with this one here too. I'll give you another example. What time to get out of here? Do you guys know? Right? What if they say, what's the value of inverse sine of 1? You go, I don't know. How do you find that out, right? You always go with this procedure. Let theta be what? Inverse sine of 1. Let that be your theta. That's what you want to find, is what theta is. What's the definition? Sine theta equals 1. Now, this is not a special triangle. What is theta? Yes. Theta is what? Pi over 2. Isn't that 90-degree angle? So you say, oh, is that my answer? Yeah, that's going to be pi over what? 2. Easy peasy lemon squeezy. This one's going to make you think. Just follow your procedure. What is theta here? You say you let theta be the inverse sine of negative square root of 3 over 2. Then use the definition of inverse sine. You say, what's the definition? That's going to be what? Sine theta is what? Negative square root of 3 over 2. You're going to have to say, what is theta? You're going to have to be careful whenever you have these negative values, okay? Because what you guys already know, I'm going to say this to you guys. You already know sine of the reference angle, which is what? Positive, means that reference angle from the last example. What was it? Right where? Right over here, right? The positive answer was what? Pi over 3, is that right? That's a reference angle. But I'm going to give you guys a little secret here. This is what you guys want to know. This is an important detail. It's so important, I'm going to talk about it. I don't want to leave you guys hanging over the weekend and you can't sleep at night because you go, what am I going to deal with that one? Where's my picture for all students take calculus? Remember that picture? This is going to be a very important detail. If you're talking inverse sine, didn't we have to restrict the domain? Right? Didn't we? Come on. I'll just do that. What is my domain for what? For inverse sine? It's quadrant 1, quadrant 4. What did you throw out? Because remember, we threw things out. What did we throw out? Because when we restrict the domain, we threw out quadrants what? 2 and 4. So even though you said pi over 3, 60 degrees, okay, that was for the what? That was for positive values. And that makes sense because that's quadrant 1, all of them are positive. But in quadrant 4, ladies and gentlemen, what do you guys know about quadrant 4? Sine is negative, isn't it? Because cosine's positive. So here's what I'm going to say to you guys. You're going to need to know about negative angles. Theta, the answer now is what? Negative pi over 3. It's not positive pi over 3. It's negative pi over 3. Why? Because how did you define sine, ladies and gentlemen? Remember we restricted the domain for sine? Go back up here. Sine is good only for what? For these values. This is the theta we're talking about. So you have positive, like 0 to pi over 2 is quadrant 1. Negative pi over 2 to 0 is quadrant 4. That's what we're going to have to start to focus on, is that you have these negative angles now. And that's fine because they're coterminal. So this would be negative pi over 3. So final answer, you say, oh, where is it at? Right here? It's negative pi over 3. So ladies and gentlemen, we just started this section. I gave you guys a lot of powerful, amazing All right, ladies and gentlemen, let's try these out here. Remember, this is really centering on the world of inverse functions. So this is where we left off. And to remind you guys, there's a process for every one of these here, right? So let's remind you guys, this is what you guys want to do for every one. Like for step 1, you'll let theta be inverse sine of negative 1. You're going to do that for all of these. So you say, okay, what about for number 2? You're going to do the same thing. Theta being, this is inverse sine. Okay, this is not reciprocal. This is inverse sine. Okay, remember this. This is the notation. These are reverse functions. Now, here, what's the next step? Do you guys remember? What do you say now in step 2? You guys looked this over and we worked on this, right? What do you guys say now? You're going to use that definition I gave you. You're going to go all the way back over here. And actually, yeah. We're going to use this definition. So what you're going to now say here, ladies and gentlemen, right, is what? You now say sine of theta is negative 1. You say sine of theta equals 0 here. And then for every one of these, the question is now going to be, what is theta? Now remember, there's something that was very important. Since I did some S, right? I told you guys about these S part. What do we have to do to the sine function to make it invertible? Do you guys remember what we had to do? What do we talk about on Thursday? What do we have to do there? What do you do now? Right, what is that? What do we have to do to get an inverse function? You guys remember? you had to restrict the domain for sine. So this is a key idea, right? We had to restrict the domain of sine. What was the domain? What were your input values? Remember, I think we colored them orange, right? So we're trying to find an input value. I want to know what theta is. What's the domain? Because without it, you can't answer the questions. So what do we restrict our domain to be? Anybody remember? Theta had to be between pi over 2 and negative pi over 2. Is that true? So this is our domain. This is what we're allowed. We're allowed negative angles and positive angles. This is our restricted domain. We can't use any other value for theta. Can't use anything else for theta. Now, what that means is, going back up here, I'm going to erase this. What that means is we threw out, ladies and gentlemen, quadrant 2 and quadrant 3. They're gone. So theta being positive is in quadrant 1. And then theta being negative is in quadrant 2, right? Because remember, all students take calculus. What does that C stand for in quadrant 4? Well, yeah, it means sine is negative. So this is a detail that students who miss these questions, they never understand that detail. Right? Here, sine is positive in quadrant 1, but for a negative angle, sine's negative. Because of the all students take calculus, we restricted the domain here. So negative, remember, if I said to you, let's draw this picture, because I'm going to have to really make this point clear, right? Here's my ray. And to rotate this negative, this is 0, this is negative 0, this is 0 to negative pi over 2. Quadrant what? 4. And then 0 to pi is quadrant 1. Okay, you guys okay with that? That's an important detail. This is what we're talking about. Now, that's generally speaking. However, questions 1 and questions 2, those questions, I'm going to say to you guys, you're not even going to use quadrants for those questions. What are you guys going to use for those questions? You don't even use quadrants for these. You say, what? What do you mean? Why are those questions special? And you're not thinking of quadrants. We'll go back over here for sine again. Okay? Sine of -1 happens when what? This is where -1 is. This is that sine curve with your restricted domain from negative pi over 2 to positive pi over 2. So sine of -1, where does that happen? That happens when theta is what? Negative pi over 2. Is that true? We're talking about the location of this point. So what I say to people, for those very special questions, you just go back to sine. You don't even go back to the quadrants. What about sine of 0 here? What's that? Theta equals what? 0. Then you get sine of 0. So you're looking at the answers here, and what I do personally is over here, this is when theta is positive pi over 2. Then you get sine of pi over 2 is 1. Sine negative pi over 2, that's -1. And here, sine of 0 is 0. This is what we're talking about, ladies and gentlemen. Okay, so those are special. I recommend you know those values because it goes from sine. This is an important detail about sine. This is why, if you guys remember, when I asked you guys to graph, what were the x-intercepts? What were the maximum values? Where does it happen at? Where's the minimum value? This is why graphing those signs were so important, because you use this information. This is all reference information. So final answer when they ask you these special kind of questions, right? This happens when theta is what? We already answered it. Negative pi over 2. You're done, ladies and gentlemen. This one is when theta is what? 0. Right? Now, what about 3? You say, okay, what about this number 3 now? Well, number 3, ladies and gentlemen, to answer those kind of questions, number 3, you do the same process, right? You're going to say, let theta be what? Inverse sine negative 1/2. What does that mean? That sine theta is negative 1/2. So we're going to try to answer the same question. When does this happen? We don't know the angle. We're trying to find that angle here, right? We're trying to find the angle theta. So when does this happen? You might say, what do I do? Here's what you guys do, ladies and gentlemen. You're going to have to find this reference angle, okay? You find the reference angle because theta here, you know something about theta. Since theta is negative, theta is in quadrant what? 4, right? This is what I'm saying to you guys. Negative sine gives you theta in quadrant 4. Positive sine gives you theta in quadrant 1. So you're going to have to do this. You're going to have to get the reference angle. Now, I'm going to say this to you guys. A lot of what I'm doing here, yes, you want to be able to know where you find these exact values. And it's a process. You follow your process. You follow this recipe. Because we're going to be studying very soon. It's the next section, solving trig equations. Trigonometric equations, right? This is the same process you're going to have to use in that setting, solving a trig equation. It's the exact same process. So get used of this idea of this restricted domain here, right? Get used of what we're saying. So you might say, how come I have to find this? Well, we need the positive before we get the negative answer. And then you need to know the definition of sine. What's the definition of sine? Do you guys remember? That's what we started the course with. What is this? Yep. And there's going to be only 2 special triangles, ladies and gentlemen. Only 2. Okay. So what angle is that? Do you guys remember? Because I just do this. I don't know the angle. But I go, oh, yeah. This is my special triangle, my 60, 60, 60. Hey, that's half. We bisected that. Oh, that's 30 degrees. Is that right? So that's pi over what? I haven't even finished my coffee. Is that pi over 6? I think so. Is pi over 6 30 degrees? I think so. Is that right? Now, this is going to give us a positive sine value. This is going to give us the positive. But what do we know? The question is, where is sine negative 1/2? So you say, where's that going to be, right? This is the question, negative 1/2. What do you guys think you have to do? Here's what you're going to do. You don't say that this is the reference angle anymore. That's not your reference angle anymore. That is the angle what? Negative pi over 6. That's your answer here. Okay, because it goes back to that unit circle. On that unit circle, if I go negative pi over 6, sine's going to be what? Negative 1/2. So for number 3, you say, what is theta now? Well, negative pi over 6. And there it is. Okay, what do you guys think? Is that pretty good? Let me share with you guys something too, just so you guys know, because we're going to put this all together, because I want to give you a comprehensive kind of understanding of this stuff. This is kind of important here, right? There's going to be 2 situations for you guys. Let's go to the TI. Now, remember, I think I have my mode set. Let's go back and double check our mode. What's our mode here? There we go. Is this set to degrees? I think I'm still set to degrees. You guys see that? Set to degrees. Okay. So, if I said to you guys, I'm going to put inverse sine, second inverse sine. Now, the negative key on your calculator, negative 1 divided by 2. Yeah. What do you guys get as an answer? What does it say? You guys see, what's the answer? Isn't that negative? So I can verify this in my TI. What about the others? What if I said to you guys, what's the inverse sine of 0? Use the inverse sine here. What are we going to get? We're going to get 0. Second inverse sine of what? Negative 1 now. What do we guys get in our calculator here? It's negative. Isn't that negative pi over 2 we said, which is negative 90? Okay, you guys okay with that? So what I'm saying to you guys here, you do have the calculator version as well, because what they're going to do for you guys too in some of these questions here, right? What they're going to say to you guys, hey, they're going to give you a situation. So I'm going to say, by the way, it's not going to be, you're going to have to use the what? Use a calculator. You're going to have to find inverse sine of, let's say, 0.123. Okay? They're going to want you to use a calculator. There's no special triangle here. Okay? There's no special triangle for this situation. I'm going to write this down. There is no special triangle. Inverse sine 0.123. Close that there. And what do we get? What do you guys get here? Do you guys know what that is? Oh, I think I got rid of it. Sorry. Oh, can you guys, what are we looking at? Let's look at the TI. Okay, I'm going to try it again. Second inverse sine of point what? 123. So, ladies and gentlemen, this mode is in degrees. So the answer you're seeing here is in what? Degrees. You guys okay with that? That's your theta. So going back to the iPad, theta was 7 point, I'm going to go to the nearest tenth, 7.1 degree. So I just want to remark that some of these questions are going to ask you to use your calculator to do this because it's useful. Okay, calculators are useful, but most of the questions that they give you, I would say, in fact, 90%, 99%, unless they say use a calculator, they're going to be special triangles. So the questions generally are special triangles, but you might see some exotic questions and they're going to tell you use a calculator. Even if it's negative, you say, what if they told me what's negative 0.854? Using the TI now. Second inverse sine negative 0.854. Close that, and what do you get? Notice what you get. You get negative angles. Is that right? So this is going to be, if we go to the nearest tenths, that's negative 58 point what? 0.6 degrees. There it is. So I want to just share with you guys, going back to all of this, how to use a calculator even for these kind of questions. That's going to be important for us as well. All right? All right. Now, so guess what? We have anybody have any questions on this before we move forward? Yes. That's what's coming up. Yeah, we also have, this is what I was starting to say. We also have other inverse functions, and not just inverse sine. You might say, Mr. Judge, what about inverse cosine? Well, let's see. Let's put down the foundation here, right? So if you said, Mr. Judge, what about cosine? Well, remember, what's the problem with our cosine curve in general? So now we get to kind of move with this. What's the problem with cosine? Remember, cosine, generally speaking, how is that defined? Well, let's go to Desmos here. See if we can bring it in. And it looks like it got rid of all my amazing. What is this from? I guess was that from the calculus class? Had some other stuff here. Do you guys like Desmos? What's the problem with cosine? You're looking at the problem. In the S course I did last week, some of you guys, if you're telling me you're getting an A in pre-calculus, but yet you don't understand anything I'm talking about here, there's a problem with that pre-calculus. I'm going to say that again. If you're getting an A in pre-calculus, but yet you don't understand what we're talking about here, I have to question the pre-calculus. Because in that course, they talk about these same ideas. So what's the deal, ladies and gentlemen, with cosine? You have a real issue. What was the problem? What is it? Nope. There's an issue here with this cosine. Should I get out and let me make this red. Here's an issue. What am I doing? What is this problem here? What is this? Here's a problem. You guys are looking at it right here. What am I doing? This is called the horizontal line test. By the horizontal line test, what do we know about cosine? We did this in our notes last Thursday. We went through all the S. What did we say that day? Cosine, generally speaking, it's periodic. It repeats this pattern forever. So you're looking at a very big problem and issue. Anybody know what that is? I'm looking at it right now. It's like, oh my God. Cosine is not what? 1 to 1. Cosine's not 1 to 1. Okay. If cosine's not 1 to 1, what's the story? What's the story of cosine not being 1 to 1? It doesn't have an inverse. You go, okay, it doesn't have an inverse. It fails the horizontal line test. All righty. So if it fails the horizontal line test, what do you guys think we're going to have to do? What was that phrase I used last Thursday? We're going to have to restrict the domain. Now, here's how we restrict the domain. Okay? It's a different restriction on the domain here. All right. What did I just do with my domain restriction? Can you guys see that there? See this curve now for cosine? I threw out a lot of values. In fact, I defined cosine only from 0 to pi. What does that mean? We restricted the domain. Now, by the horizontal line test, what does that mean? Don't I hit the curve in exactly one spot? Do you guys know what I'm saying? I hit this curve only in one spot. What does that make my cosine curve? 1 to what? 1. 1 to 1. Okay, so, all right, so let's do this here. I'm going to import in Desmos that picture as well. Okay, so take a look at this here, ladies and gentlemen. Now cosine is 1 to 1. Okay, just going to send. Oh, come on. What happened here? Okay. So to kind of remark here, let me move this down here because I typically want to do the following. Your domain is restricted now, but it's restricted in such a way to make it 1 to 1. So now there's an inverse. And your x and y values, notice from this graph, these are important details. My input values are now between 0 and pi. We restricted the domain. We have to. We have to make it 1 to 1. And your y values are now between -1 and 1. So, okay, cosine's now restricted. So, since we restricted cosine, All right, what's the story now? We now have an inverse. So if you look in your text, you might start to see how it's defined now. Now we can talk about an inverse. We switch the domain and range. So I'm not going to go through all the details I did last time. So we switch your x and y values. And because you do that, you now have, by definition, this is what you're going to have here. They say, okay, you guys remember what I'm talking about? If I went through that three-step process, right? You got that y for the first step. Y equals cosine. Switch your x and y. X is cosine of y. You go, oh, x is cosine y. Yeah, step 3. Now solve for y. You can't really solve for y algebraically, so you pretend. And then that last step is to say, oh, here's your inverse function. Okay? So just like before. Just like before. So what happens is you're going to get the definition in any book of inverse cosine. They define it in your book this way. Inverse cosine of y is equivalent to this statement, cosine y equals x. Okay, so they're going to go back really to right in here, right? This is some of you guys, again, in pre-calculus, you're going to switch your x and y. So we talked about this last time in the S portion. Okay? And so here's really what this all means again. So they're going to say, okay, what are we talking about? Well, you have another function called that inverse cosine function. If you switch the domain and range, what is it defined for? See, this x and y are switched. So that means you can only use this for x values between -1 and 1, and the y values are between 0 and pi. This is switching x and y. Okay, put that in your notes. What did you switch? Domain and range. Switch your x and y values. You switched this, okay? These are the x and y values that got switched. And so if you said to me, okay, then what does that inverse cosine function look like? Well, okay, Desmos. Desmos is going to tell you. Here we go, Desmos. This is that new curve now. So these are the new, these are additional curves in your life that never existed until today or this week or last week. These are called the inverse trig functions. Okay? That's where they come from, ladies and gentlemen, these inverse trig functions. Okay, so you have new curves that you've never seen before, but this is the whole process. They come from restricting the domain for sines, cosine, and even tangent, and now you have these very new functions. And then the question is, can you use them now? Now that we see where they come from, you know, they're going to ask us, how do we use them now, right? So they're going to say, to evaluate, you're going to get the exact value. Evaluate the following again, right? So question 1, they might say, find inverse cosine of 1/2 this time. So this is the question we had earlier. Hey, can we talk about the inverse cosine curves? Yes, we're going to do that. Of course. So here's the process. You're going to let theta be inverse cosine of 1/2, okay? And when you do that, you say, what happens when I do that? Well, you see this definition here? If this is my theta, that's what's going on in the definition here. So that's your theta. So now, that's your theta. So what that means is cosine of theta is 1/2. You can even say by definition. We could do this in like proof format there. Now, the devil's in the details, ladies and gentlemen. I want you guys to go back here because now, essentially, this is what we want to know. We want to know what is theta. What is theta, ladies and gentlemen? That's what we want to know. Now, what is that? This is going back to what did we do to cosine? You guys remember what we did to cosine? Now we get to go back to geometry and trig. What did we do when we restricted our domain? Do you guys know? Because this is going to be that theta they're talking about. This is what I always want to make reference to. You had to restrict the domain. Okay? Oh, we even put that there. You restricted that. That's your theta. What did we throw out? Notice what did we throw out? If you guys really looked at the details, from 0 to pi for theta, these are my input values. Isn't that quadrants 1 and 2? I want you guys to understand this. This is different. This is quadrant 1 and quadrant 2. This is not like inverse sine. Theta is between 0 and pi. That's quadrant 1, quadrant 2. We threw out quadrant 3, quadrant 4. So that's gone. And you go, what do you mean? Yeah, that's gone now. So when I bring in my all students take calculus, that's what we need. You know, I want to bring in that picture. I'm going to cut that one. Gone. Okay, so here's what I want people to see. We threw out, what did we throw out? Quadrant what? 3 and 4. This is an extremely vital piece of information because now there's no such thing as a negative angle now. You see, theta in quadrant 1, right? This is cosine theta for theta is positive in quadrant 1. And if you have an angle here in quadrant 2, right, what do you guys know? This is still a positive theta. This first angle is still a positive theta. But what do you guys know about cosine in quadrant 2? I'm going to get out the red. Cosine in quadrant 2 is what? Negative. So there is no negative angles for cosine, for inverse cosine here, because we defined it to be only quadrant 1, quadrant 2 angles. Remember that S in quadrant 2 means sine is positive? Okay, remember all students take calculus? So what happens now, you take your ray, here's your ray. Quadrant 1, it's what? Positive. Quadrant 2, cosine's negative. So we had to throw out these other quadrants. We only have cosine defined for these two. And that is it, ladies and gentlemen. That is it. All right, you with me on that? That's it. That's an important detail. So if you said, how do I find this? Well, go to your special triangle for cosine now. What's the deal here? What's the definition? Isn't it adjacent over hypotenuse? And then isn't that a special triangle? Right? What's theta going to be here, ladies and gentlemen? Right? Didn't I use the definition of cosine being 1/2? So what's that special triangle going to be? 60 degrees. Outstanding. Pi over 3. That's your answer right in here, ladies and gentlemen. So the final answer here, we say, okay, this equals pi over 3, 60 degrees. And that's how you do this. So if you even said, what happens with inverse cosine? This is what happens. And then similarly, give you another example related to this one. You said, but what if they gave me negative, what, 1/2 instead? Right? They gave you positive 1/2. Yes, you got to go to your special triangle. What if it was negative? What's the difference? Be careful. This is inverse cosine, right? So we're going to say, let's go through the process. Let theta be what again? Inverse cosine negative 1/2. What does it mean about your cosine theta? Isn't that what? It's negative 1/2. Now, the problem is cosine here is negative. What did we say before here? You're going to have to go to your what? Reference angle. Because cosine is, in fact, negative. So you go to the reference angle again. And now your special triangle is for the reference angle. You say 1, 2, definition of cosine. And yet again, what do? 1, 2. What is that theta going to be? You said that was the same as the last one. It was. What do you say theta was? Where is it? Oh, I guess it's going to be what? 60 degrees. Is that right? So my reference angle is what? 60 degrees. That's the reference angle. How does that work if you call it reference? Go back to your picture here, right? This is that 60 degrees. Isn't that the reference angle? This is the important details that we'll see even in the next section, which is big, solving trig equations. That's your reference, 60 degrees. What do you think? What's the angle theta, though? right? What's theta going to be if that's 60 degrees? Isn't that what? 180 minus the reference? Isn't that how we get it, right? That's the angle. What angle is this? It's a quadrant 2 angle. What angle is that, ladies and gentlemen? That's 120 degrees. This is the important detail. That's important. Now, you might say, what is that in terms of radian, right? So, okay, you can say, isn't that pi then? Isn't that 180? And then pi over 3 now. Is that 3 over 3? And what's theta going to be? Isn't that 2 pi over 3 now? So your final answer is going to be now here, theta is 2 pi over 3. So what's important is that you go through this process. Two pi over 3. And it's not a negative angle because inverse cosine is defined differently than inverse sine. All right, you guys okay with that? Anybody have any questions on this one here? This is a process that I think, ladies and gentlemen, it's important because you're going to see this in the next section. So even if they say, okay, what about inverse cosine of square root of 3 over 2 now, right? You follow that same process. You're going to let theta be what? Inverse cosine square root of 3 over 2. You're going to find theta now. Now that means cosine theta is the square root of 3 over 2. All right, you guys okay with that? So what do you think you guys do now with this here? Do you guys know? What do you think you do? What's the definition of cosine? Right? Isn't that adjacent? Square root of 3 over what? Over hypotenuse? So what do you think this gives us? What's this side over here? Do you guys know what this side over here is? I think that's 1. Is that true? Isn't that a special triangle here, ladies and gentlemen? Told you. Special triangles, they're essential. So when I see this, oh, here's 1, here's 2. What's your angle theta going to be? What's theta? And that 30 degrees, which is pi over what? 5 or 6? So this is the angle theta that they're looking for, right? This is pi over what? 6. Here's your theta. Pi over what? 6. There you go. Okay, you guys okay with this? Now, I'm going to give you guys a note here just to see if you guys are on top of that, right? Here's a note. What if they give you inverse cosine negative square root of 3 over 2? Right? See if you're awake with this. What would happen now if they did that? Right? Don't they say again what? You're going to let theta be what now? You go through your process, let theta be the inverse cosine of negative square root of 3 over 2, and that now means cosine of theta by definition is negative. And then you might say, oh, because this is negative, what do you guys need again? Don't you need a reference angle? You need the positive value reference. But you already know what that value is. You got that in the last example, didn't you? What was that here? Wasn't that 30 degrees? So you say, oh, that was 30 degrees. So how does that work? Or pi over 6, right? Same thing. So how does that really work? Bring in your all students take calculus. So for cosine, we throw out quadrants, what? 3 and 4. Is that right? Cosine's negative. So ladies and gentlemen, you're talking a reference angle here to be what? 30 degrees. What happened to my marker? It's weird. Okay. Right? Why? Why is that over there? Because this is where cosine is negative. So what's the angle then? What does theta have to be? Do you guys know? Cosine's negative over here. Right? So what's the angle? Isn't that going to be what? Pi minus pi over 6, which is 30 degrees. Is that true? Isn't that going to give you 5 pi over 6? Why is this 5 pi over 6 for theta? You guys know? How do you do the arithmetic? Isn't that 6 over 6? Theta is 5 pi over 6. So here it is. And there it is. There you guys go. So what about these others? I want you guys to note these others here, right? These are the ones that you don't go through the process for. Okay, so I want you guys to understand the details here. So you say, what about this? You don't go through the process. These three here. I mean, you can, but it's not the complete process. Let me go with that again. If you call this theta, we need to know, by definition, where is cosine theta 0? Is that true? Do you guys see what I'm saying? You're going to look at the graph. So for these, you get to look at the graph. It's very simple. So you're going to look at the graph. You go, okay, where is cosine theta equal to 1? Here's your theta. Cosine theta equal to -1. So for these here, I'm going to say you want to look at the graph. And you say, what graph? The graph for what? Cosine. Cosine. The graph for cosine. Well, where's your cosine graph? It's what we started way up here. Right? What am I talking about, ladies and gentlemen? I'm talking about these special locations again. The maximum value, the intercept, the lowest value. This is why we gave you guys that stuff on your second test. The graphing. So what does this mean, right? What angle of theta is this? This is where theta equals what? 0, is that right? So are we saying that cosine of 0 is 1? Isn't that true? This was an intercept, right? Where do you have the intercept? What is this? This is pi over what? 2. So cosine pi over 2 equals 0, ladies and gentlemen. Wasn't that the first test that we were talking about? These special points. Where is this? Isn't that the lowest value? That's pi. So that means cosine of pi is -1. These are all those answers that we are what? Looking for. 1, 0, -1. Easy peasy lemon what? Squeezy. So that's essentially what these answers are here. Right, where's cosine 0? Theta is what? Pi over 2. That's what we just answered. Where's cosine 1? Theta is what? 0 degrees or 0 radians. Doesn't matter. It's what we just answered. -1, theta is what? Pi. And there you go. What about this? What do you guys think you have to use here? Do you guys know? What do you use on these? You use the what? These are using the calculator. So we don't even have to, we can go through the process, or we can just go straight and go, okay, I'm going to use my inverse cosine. Inverse cosine. TI. Okay. Second, inverse cosine of what? 0.123. That's using your calculator. These are not special triangles, right? And if you go out to the nearest tenths, remember, this is set to the degree mode. So this is 82 point what? 9 degrees. Second, inverse cosine, negative point what? 567. Close that. What do you guys got? 124 point what? 5 degrees. So for these, again, these are not special triangles. Okay, so I want you guys to really know that here, because if you did go back to that, you might say, hey, Mr. Judge, what if I did go back to some of that stuff, right? Well, if you said, I want to say, let theta be inverse cosine of 0.123, that does mean cosine is 123, right? Decimal there. You guys see what I'm saying? I could draw a triangle, but there is no special triangle now. I can write that 0.123, right? There's no what? There's no special triangle. You can't use that classical approach. In fact, you know the answer, that's 82.9 degrees because you use your calculator. Okay, you guys see the point? You use the calculator with that one. I mean, that's the essence of this. This answer, the angle is what? This is not a part of a special triangle. And we did have a worksheet on, doing inverse cosine when we did law of cosines. Remember that? You guys remember my point? So it's kind of weird. Like in the law of cosines homework, they wanted you to use a calculator for this. But in this section, this is where they really start to dive deep into the details behind it. $82.9 degrees, 124.5 degrees. Okay, what do you guys think? Is that, let me look at this here. All right, so this is actually inverse cosine. So I want to just kind of conclude here to remind you guys of some facts about inverse functions. Remember that? Inverse cosine of cosine is x. And then cosine of inverse cosine is also x. And this only is good for x being between anyway. Give you some inverse cosine information. Zero to pi, because we had to restrict the domain, right? And this is going to be between -1 to 1. But this is, again, going back to the issues where you guys had composition of functions in general, right? So you say, what do you mean? Well, if you go back to the generalization here of any function and its inverse, you had that relationship back in the day. There you guys go? You guys okay with that? Anyway, let me see. That's weird. This computer just went crazy. So let me double check in Canvas for you guys. Yeah, you guys already have homework in Canvas. Is that right? Do you guys know what I'm talking about? 7.4. So we're gonna continue with what tomorrow? Which function do you think we're gonna do tomorrow, you guys? Anybody have an idea? What function should we stay tuned for tomorrow? Inverse tangent. Good job. Make some sense? Okay, we'll see you guys tomorrow. Take care and have a wonderful day. Get started on these, and we'll see you guys later. So, I guess I'm being echoed out there, maybe? All right. Good morning to you guys. Good morning. Let's see where we at here. We're in the iPad. So we are going to continue with our inverse trigonometric function information. This is important. Everything I do is important, but nevertheless, I only do important things. Let's talk about tangent here. Remember this? So we're going to look at tangent this morning and try to do some more work here. Now, I want to remark about tangent. Let's remark there. If I go to Desmos now, where's Desmos? We're going to do tangent now. So I'm going to share with you guys tangent. Y equals what? Tangent x. I don't know what that happened. So take a look at tangent while I bring down the screen. That was weird. All right, so let's get this a little bit bigger for you guys. So I want you guys to really look at this. And I'm going to remind you guys a bit about something here. What's the problem with this tangent curve? Okay, really, actually, we don't really want this curve. Okay, let me go back to Desmos. What's the problem with this tangent curve? I'm going to do this thing again yesterday, like I did yesterday. Anybody remember? What's the real issue? Yes. It's not one-to-one. It doesn't pass the horizontal line test. Is that right? So remember, the horizontal line test is a very big deal in math, right? So this thing is not one-to-one. You know, it's not one-to-one. So it doesn't pass the horizontal line test. So we have to restrict the domain. Now, how we restrict the domain for tangent, to make it 1-to-1, we got to restrict the domain. So let's do that here. We're going to do from negative pi divided by 2 less than x less than pi divided by 2. So notice what happened with that restricted domain now, right? If we take a look, notice what happened. What happened now was what? Now it's 1-to-1, and the reason it's 1-to-1 is because we restricted the domain. We had to throw a lot of information out, but we still have some information that's useful. So we restrict the domain, and we're going to throw this. We're going to throw some values of x out to make it 1-to-1. So now we have an inverse, and that's the whole idea. Okay, so there we go. Where'd you go, picture? Got to do it again. There it is. Okay. So what you guys are looking at here is the graph of tangent with a restricted domain. So now your values of x have to be between negative pi over 2, positive pi over 2. And what happens now is your values of y are really any real number. Okay, so we had to restrict our domain to make this 1-to-1, and now we're going to have an inverse. But I want you guys to know this extremely important fact here. Okay, it comes from restricting the domain here. That if you really noticed, your values of x or theta, because sometimes we call it theta, they're between negative pi over 2 and positive pi over 2. Okay, so we restrict the domain. If you notice, you said, what are you talking about? Right in here. This is really quadrant 1 and quadrant 4. So I'm going to add this here for you guys to understand it as reference. I'm going to add that picture of this restriction. Okay. So this is an important detail that we're eventually going to use to say we had to throw out quadrants 3 and 4. Because positive angle, if I bring that ray, right? This positive angle here, if I go into quadrant 1, this tangent is positive. So I want you guys to know, quadrant 1, tangent's positive. But if we go with a negative angle, that means we rotate clockwise. This means cosine's positive, right? But what does that mean? Tangent is negative. So I want you guys to know that this is for a negative angle theta, because we rotated clockwise and then counterclockwise. This is a positive angle theta. So this is the restricted domain part. We threw out quadrants 2 and 3. This is what I'm referring to make this 1-to-1. So to make this 1-to-1, we had to throw those things out, right? Anyway, okay. So here's the deal now. Restrict this domain. So here's the deal. We're going to give you guys the definition of the inverse tangent function, right? Because it goes through that same process. And I'm going to erase this, but it goes through that same process. You say, okay, let y be tangent x. Switch your x and y. That's the key. Switch your x and y. And then solve for y. You really can't solve for it, so you just say, we pretend you solve for y. Now you have the inverse tangent. And then you say, okay, here's our inverse function. This is stuff we talked about a few days ago. If you're taking those other courses, they should be going over this if they're doing it right. Okay? If they're doing it right. So now we have over here the inverse tangent. And where this comes from is they'll write it down this way. They say, okay, inverse tangent of x equals y is equivalent to saying tangent of y equals x. Okay? Now you might say, again, where did they get that? They got it right in here, step 2, step 3 of trying to find an inverse tangent function there, solving for y. That's the short procedure. Okay, and so now they go, okay, if you have that y, remember, is inverse tangent, and we're switching domain and range, because that's what you just did in step 2, switching the x and y values, then now you go, okay, what does that mean now? Well, these are switched. That means x is any real number, and the y value is between negative pi over 2 and positive pi over 2, because they're switching x and y. So this is where this all comes from. Switch your x and y, and we are. And now you have negative infinity for x, and then y is negative what? Pi over 2, positive pi over 2. This is what we're looking at. So there it is, ladies and gentlemen. We're not going to have to see how to use it. But before we do that, let's import the inverse tangent curve. This is a very important curve, right? So you guys know I teach the calculus course, calculus 2. I teach all those courses. And this is inverse tangent curve. And that's, also part of the inverse function family of curves. So I'm going to bring this in. There it is. Oh, that's the old one. That's not it. So, oh, there it is. It's kind of weird. Thought I lost it. Just really low. And there you go, ladies and gentlemen. This is where this all comes from. So, if you take those other courses, you guys are going to see this stuff again. Okay, good morning to all those people. Look at that, all you guys at home. Good morning to you. Anyway. Okay. Now you might say, okay, how do we use this? Well, maybe we should start simple. No, we don't have to start simple. I don't know how we want to start. See how to use this, right? Well, inverse tangent of square root of 3 over 3. You're going to let theta be inverse tangent square root of 3 over 3, which now means tangent theta is the square root of 3 over 3. Okay, so we're using again the definition. Remember this here? Where is that? There it is. They're using this definition here. So if you ever have inverse tangent of anything, equals a value, that's what that means. This is equivalence. So then you say, okay, Mr. Judge, what am I supposed to know now? Well, go back to your special triangle situation, your right triangle, okay? What's the definition of tangent? You guys remember? What's your definition? Opposite over adjacent. So that's going to be square root of 3 over 3. Okay, this is going to be, for the most part, when they want you to get these values, they're special triangles for the most part. Okay, and then you're going to go, but I don't remember a special triangle like this. Well, do you guys know where this came from? Isn't this going to be? Let me say this. Isn't this come from 1 over the square root of 3? Do you guys remember that one? So that came from 1 over the square root of 3. So if you said to me, can I use that better? I might, personally. Opposite over what? Adjacent. I might use that. You know why I might use that? Because now that looks to me like the special triangle that I know. Just the opposite over adjacent definition. Right? You guys see what I'm saying? And then you go, okay, what triangle is that? Do you guys know? Anybody know what triangle this is? Yeah, this will be 1. This is 2. This is 2. So theta is 30 degrees. You are right. So that means theta is pi over 6 here. Okay. pi over 6. There you go. Easy peasy lemon squeezy. Okay, I just want you guys to know it's going to be a special triangle. So I think of it as 3 situations. You got the special triangle situation. This is why I always start with that. And that's why you only need to know those 2. And then I'm going to give you guys a note where I always go after this is, it's another example. But what about the negative version, the negative value in the inverse tangent? You want to know that too, because you can start it the same way. You're going to let theta be the inverse tangent of this value, right? It's done the same way. And then that means tangent theta is what? -1 over the square root of 3. Now, remember, this is going to be the concern here, okay? That negative value. Now, the second you see a negative value, I want you guys to go to the reference angle, because the reference angle is the +1. This is always that quadrant 1 angle. That's your point of reference. This is why we use that reference angle notation. And we already answered that one. We already know, based on the last example, that that was 30 degrees. So, I mean, you would, though, if you said, if I did this all from scratch, would I do my triangle again? Yes. And then you find that, oh, yeah, it's a 30-degree angle. Okay, so that is pi over 6. So you guys know that. But it's working a little bit differently here now. I want you guys to really think about this, because this is going to be part of what we're going to see, you know, the rest of this week as well. We got to work on this over and over again until you guys become those experts. Pi over 6. Now go over here, ladies and gentlemen. Remember I brought this up here. You go, but Mr. Judge, how do I give an answer when tangent's negative? Remember, this is really what we're looking at. The tangent for a negative value there, right? So where is tangent negative? Quadrant what? 4. We used reference information. Remember this? This was like on the unit circle. If I can draw one again. This is the angle we're talking about right here. Okay? That's the 30-degree angle, but it's negative. And you say, why is that negative? Because we only allow positive angles between 0 and 90 degrees. Okay? Tangent's positive here, between 0 and 90. But if I rotate counterclockwise, all these values for tangent are negative. So the final answer is going to be for theta, it's negative pi over 6. It's the negative angle version. It's negative 30 degrees. Okay, because you're going to have to rotate in this direction. How do we say? Counterclockwise. Well, sorry, clockwise. I apologize. That's a negative angle. That's why you need this reference information, because you restricted the domain to include negative angles. Negative pi over 2 up to 0 is quadrant, that quadrant down there. That's where tangent's always going to be negative here. So the final answer is negative pi over 6 here. That's what you write down here. And that's it, ladies and gentlemen. So this is how we start to get a handle on those, inverse tangent kind of situations here, right? Give you another example here of this. It's -1. Let theta be what? Inverse tangent of -1. Tangent theta is now going to be what? -1. What do you guys do again once you see that negative value? What do you guys do? I'm getting out my purple. Anybody know? Why am I having the purple marker? What do I have to do? Tangent now of what? The reference angle is 1. Okay, so the second you see tangent being negative, you got to go, okay, tangent theta, the reference angle now is 1. We're going to use reference angle information. But be careful, because remember, when we draw our right triangle, we need an opposite over adjacent for tangent. So if it's just a whole number like that, 1, then put this 1 over 1. But then you have to identify what special triangle is this. What do you guys think? What is it? What special triangle is this? Do you guys know? You only have to know 2. If we have opposite is 1, adjacent is 1, isn't this the square root of 2? By Pythagorean theorem, right? Isn't that square root of 2? So what special triangle is that? Do you guys know? Yep. There's only 2. You got to know. So that angle is 45 degrees. You guys want to know this. This is why we're going to go through these things in some detail, okay? Because this is important detail. People don't think it is. They overlook it. They think, okay, I'm going to use my calculator. I don't need to understand where anything comes from. Now, that's a positive value, right? Tangent theta is positive 1, but we have tangent theta is -1. What is that going to mean, right? So remember, go back to that picture I brought in. All students take calculus. Tangent's negative in quadrant what? 4. So how does this reference work? Right? Tangent's negative in that quadrant. So that means you're going to have to rotate how? Clockwise. How? How do you rotate? Clockwise, how much? -45 degrees, but it's negative because it's clockwise rotation. Is that right? So the angle that we need is negative. It's a negative angle because you restricted your domain. Okay, remember this? You threw out really quadrant 2, quadrant 3 because the angle's between -π/2 and +π/2. So this is the small detail that people have to remember, that you threw out quadrants. In one quadrant, tangent's positive. The other quadrant, tangent's negative. But to get there, you have to rotate a negative rotation there. So this answer is going to be a -π/4 here. All right. So anyway, ladies and gentlemen, there it is. And that's what we want you guys to learn. All right, and then let's give you guys over here. What about this here? What if they give you inverse tangent of 0 now? Okay, you guys want to know this one too. Inverse tangent of 0, right? So if you go through the process, it's helpful for me to always go through this process, ladies and gentlemen. Remember this. Now use the fact that tangent theta equals 0. You're using the definition of inverse tangent now. And you have to answer what theta is. Now this is tangent theta equals 0. Okay, tangent theta equals 0. Now, where is tangent theta 0? Go back. I'm going to the tangent curve. I'm not even looking at the inverse tangent curve. I'm going back to this information always. Okay, you guys okay with that? And I'm trying to answer, where is this 0? Okay, tangent theta is 0 for what location? Now, remember when I gave you guys those graphing tangent and I asked you, hey, where is what? Where is these intercept values? Right? You're looking at an intercept. Is that true? This is where tangent crosses your x-axis. So that's 0 and that's 0. That's the location. So do you guys know what this means? What does the angle have to be? 0. Good. Outstanding. This is your answer. So having to read your graph and find those locations is also important, ladies and gentlemen. This is why I did that with you guys. This is why I made that worksheet, did those videos, poured out all my blood, sweat, and tears. This is why I do it. Theta 0. All right, you guys okay with that? So these are kind of the couple of second kind of situation. There's no right triangle here. So you say, Mr. Judge, why didn't you draw a right triangle? Well, there's no right triangle that you can have a 0-degree angle like that, right? Where tangent 0. There's no right triangle. Now, obviously, 0 degrees is not a right, you can't draw a triangle with a 0-degree angle. So there's no special triangle. But what's the last situation, right? You guys should know this one, what's coming here, right? They're going to ask you as well, see if you guys know this. One, two, three, 4. Okay. And you say, wow, what's going on here? What do they mean for me to do here? What do you guys think? Exactly. So you're going to see non-symbolic values here. I mean, yes, the process is what? You said, can I let theta be that value again as well, right? We want to know what theta is. Okay, so this is a calculator question here, right? There's not going to be a right triangle here that you can draw So it's not a special triangle situation. So we're going to go to the calculator now. So, it's good to know how to use this. And that's all. It's an exercise in using the calculator. So find inverse tangent. 1.234. Close that. What is your angle? This equals what? If we go to the nearest, we're going to approximate to the nearest angle. If I go to the nearest tenths, you guys know what that is, the nearest tenths? That's going to be, here's what, let's go through that and take a look at this, right? So if you said, where's the tenths position? I'm going to go to the tenths right here, okay? Look at the digit to the right, and it's a 7. That means add 1 to the 9. We're going to get what? 51%. So my angle theta is 51 degrees. So theta is 51 degrees. Easy peasy lemon squeezy. This is about using the calculator. And what if they give you inverse tangent is negative 6.015 now, right? Right? You can do this again. You can say, okay, I'm going to let theta be what? By definition, inverse tangent, negative 6.015. That now means tangent of theta is going to be what? Negative 6.015. And you say, what is theta? Inverse tangent, this is going to be what? Negative 6.015. Close this. What's the angle theta? What's theta going to be? If we go to the nearest tenths again, what do you guys think that's going to be? What digit is in the tenths position? The 5? Digit to the right's a 6. What does that mean? Add 1, and now that's going to be what? Okay, ladies and gentlemen. And there you go. All right, now, what I want to share with you guys here is how to use these inverse tangent functions and kind of, I mean, you guys want to know about physical situations. It's a word problem, but it's not. It's a physical situation. Oh my God, I hate words, right? Let's go back to, this is a very, very famous kind of situation, the height of a balloon, right? What if I said this to you guys? I won't even use words. I'll draw a picture. I want to draw a triangle. Okay, this is where your balloon would be, by the way. Okay? This is kind of a classic kind of demonstration. And then they're going to give you like maybe the rope. This is 500 feet rope. Okay? And the height, this is where your H is. Okay? Now remember, what do we call this here? This is going to be known as your angle of elevation because you're going to put your eyeball here. This is where you have that horizontal, right? Just kind of remind you guys, this is the horizontal here. All of that stuff is kind of back. So if they said to you, and they'll say this to you, describe theta as a function of height h. Okay? Describe theta as a function of height h. Now, I want you guys to understand this here. You say, what does this language mean, right? What they're saying is theta needs to be f of h, okay? This is the language. Describe theta as a function. Remember this here? I think I'm going to use another color. A function, that's f. A function of what? This h. That's f of h. So they're saying, can you describe my angle theta as a function of height h? This is the language and this is the meaning. This is the theta in the picture. I guess this is my height here, okay? Now, do you guys know the secret to this here? What's the real secret? You guys know the secret to working with this. This is a classic question. What trig ratio, go back to geometry, what trig ratio is opposite over hypotenuse? Isn't that what? Sine theta is opposite over the hypotenuse. You guys okay with that? That's the trig ratio that you know. So what happens now, ladies and gentlemen, is this. They're going to say something like this to you now. You're not done, okay, because you did not describe theta. We got to get theta by itself, okay? I'm trying to find the colors. Okay, there's my h. How do you get theta by itself? Well, there's a couple of ways to do that. Remember this fact I gave you guys before? There's a couple of ways. You can say inverse sine theta. Isn't that theta? I could do a couple of things. I can use this or just the definition of inverse sine. So what I'm saying is, if you say, can I do this, Mr. Judge? Take inverse sine of both sides. Take inverse sine of both sides, and I'll get now theta is going to be what? Inverse side h over 500. Well, and you said, can I just go straight to my definition? You can. What's the definition? Right, theta will be what? Inverse sine h over 500. That's by definition. So what you have is now a nice function, ladies and gentlemen. This function gives you theta for any height h. Okay, so you have a balloon there. That function, if you give me h, I give you theta. Give me h, I'll give you theta. Now you go, what do you mean? How they really think of this way, though, is this way, right? I'm gonna get rid of this highlighter, if I can. This is how you guys want to think of this thing. For the various height values, all the different height values of that balloon, you have different theta. Is that right? You change the height, I'll give you a different angle of elevation, theta. Because there's your height there. Give me a different height value, I give you a different theta, angle of elevation. That's kind of how you want to think of it. So now they're going to say, let your height be, right? Like if your height is 100 feet, what is theta? So what they gave you is h. So they're going to give you this h value. You go, okay, h is what now? 100. So theta will be inverse sine of 100 over 500. Now you're going to use a calculator. Use your calculator. Okay, so here you go. You go, okay, this is why they had me do the inverse function. Yeah, now put what? 100 divided by 500 in your calculator. Close that. You know what the angle is? And that's in degrees, by the way, ladies and gentlemen. So go to the tenths. That angle is about 11 point what? 5 degrees. Let h be 250 feet. What is theta? What did they do? They changed the what? They changed the height. So now you might say, okay, theta will be inverse sine of 250 over 500. Let's see what this is going to be. What's your theta? What's your angle? 30 degrees, ladies and gentlemen. So they're going to have you change your various height values. You're going to use your calculator on this. Okay, now they say, okay, here's going to be a fun one. Let theta be, I'm sorry, not theta, let h be. Let's let the height be somewhere like 1,000 feet. Oh my God, what if the height is 1,000 feet? Right? What's the angle of elevation now? You're looking up. Theta is going to be inverse sine of that 1,000 over 500. And then we might say, okay, what is that? Maybe there's a problem. I don't know. Second inverse sine 1,000 divided by how much? 500. Close that. What do you get? You go, there's a problem. There is a problem. You go, why was there a problem? Do you guys know why there's a problem? The definition says sine theta is going to be 1,000 over what? 500. Sine theta is 2. What's the story here? This what? Never happens. How come this never happens? Yeah, sines between -1 and +1. Okay, because remember this one, sines between -1 and +1, ladies and gentlemen. It's a deal. Now, one of my all-time favorite questions is the rocket question. Okay? And, you know, they can say the height of a what? The height of the space shuttle. Height of a rocket. You got an angle elevation here, and they're going to say, you know, this is 3 miles to the base of the launch. Now you have a rocket ship. That's my rocket, sorry. There's the rocket. And this is going to be your height. So they're going to say again, I'm going to say express h as a function of theta. Okay, so what you guys want to do, you're going to read this here. You say, okay, h needs to be what? Function of what? Theta. Okay. H equals f of theta. So I'm gonna go back again. I'm gonna ask you guys, remember your geometry. You got opposite over adjacent. What does that mean? Anybody know? Be careful. Isn't this what? Tangent what? Theta equals what? Opposite over what? Adjacent. That's just writing down your trig ratio. Tangent theta is defined to be h over 3. Now, you might say, well, what does that mean? I can solve for h by multiplying 3 to both sides. I get 3 tangent what? Theta. That's what they want you to do. That's all. They're just saying h here is a function, f of what? Theta. So h is a function of theta. That's it. This is your rocket situation. A rocket is launched from a, this is where the launch site is, by the way. And then if they told you the opposite, so you might say, what if they write it down the other way, right? They're going to ask you to express theta as a function of h. So what they're saying here is they want theta to be, oh, we want the highlighter, function of h. I guess I'll change the color. I don't know. Okay. So when they use that phrase, I'm going to show you guys how to translate that. That's theta equals f of h. There's your theta. Okay, you guys okay with that? Now you might say, Mr. Judge, how do we do that? Well, a couple of ways here. We can say, remember, those inverse function relations here. I can say, I'm going to take this expression here. I'm going to copy this. And I can use it. Or I could use the definition. The definition of what? Inverse tangent. The definition of inverse tangent is h over 3. That's by definition. And this is really what they want you to do. Okay, so this is the very famous looking at a physical situation and how you're going to apply the inverse trig function relationship. Because now they can say here, what is theta, the angle of elevation, when the height of the rocket is 5 miles in the air? Right? They're now going to say, can you give me the angle of elevation when h is 5 miles? Well, that's 5 over what? 3. Is that right? So you go to the TI, and this is, again, why they had you do the calculator versions here. So say, okay, look at this tangent, inverse tangent, 5 divided by 3. This is why you want to know how to use that too as well. What is that angle of elevation to the nearest degree? Let's do degree here, okay? Let's do, yeah, it's degree. That's fine, whatever. 59 degrees. So you have a 59-degree angle of elevation there, ladies and gentlemen. What do you think? So they're going back to here, and they say, what happens when this thing is 5? Okay, if this is 5, angle of elevation is 59 degrees. 5 miles. I wonder if we can find out the angle of elevation when the height of the rocket is 10 miles. What do you think that's going to be? Inverse tangent 10 over 3. Can you use the calculator? Yes, that's the whole idea. Second inverse tangent 10 divided by 3. So notice this. This will be 73.3 degrees, ladies and gentlemen. So your angle of elevation is 73.3 degrees. Anyway, I'm just looking at a few things here. Okay. All right. So, anyway. All righty, ladies and gentlemen. Here's the deal. What am I going to do here with this? I'm going to double check something here for you guys in Canvas here. I'm going to adjust your homework. So we said, what are you doing? I'm looking in Canvas here. I'm going to adjust your homework on 7.4 inverse functions. How's that? And I think I'm going to stop here. Okay, I think I'm going to stop here for the day for you guys there. So this is on inverse functions. So I'll let you guys go and get started on that homework. And we'll proceed tomorrow. Okay, so I hope you guys enjoyed the lecture. Good morning to all of you guys at home. What do you guys here? We got Palace Doc is at home. Isabella's at home. Yi Cheng, Kurapat's at home. And Jonathan Cervantes is at home. So, okay, you guys, good morning to you guys, or good afternoon. We'll see you guys tomorrow. And take care. Stay safe. And I'll let you guys get started early. Have a great day.